T&H Lamont's TIG mills can produce tuber pipe as small as 90 thousandths of an inch in diameter and as large as 10 3/4 of an inch in diameter. Corresponding wall thicknesses range from 6 thousandths of an inch to a ½ inch. This video, which is an overview of the components and features of T&H Lamont's TIG mills, is based on model WU11M-12, which produces tuber pipe in diameters from 1/4 inch to 1 inch, with wall thicknesses from 20 thousandths of an inch to 65 thousandths of an inch. In addition to the mill, this video also covers the upstream and downstream equipment. It includes the equipment that feeds the raw material into the mill, a welding unit, and a cutoff system. Some production lines include many other processes, such as annealing, coating, and non-destructive testing. T&H Lamont makes some of the items for these processes and purchases others from a network of trusted suppliers. This video provides a brief description of the entire process. It starts with the raw material, a coil of metal strip, and traces its path through an entire production line. In this case, the production line consists of 4 discrete sections as follows: an entry section, the mill, a pull-out section, and a cutoff. This mill also includes an inline annealing system, which is not shown in this layout. The annealer is located between the mill and the pull-out section. The entry section consists of 3 components: an uncoiler, a shear end welder, and an accumulator. These work together to feed the mill a continuous strip of raw material. The first piece of equipment on the mill is the encoder, which measures the raw material. From there, the strip moves to the entry guide table, which guides it to the forming stands. The forming stands use matched pairs of rolls that form the raw material into a tube. Following that is the welding section. This section has the weld box, which provides an inert atmosphere and is equipped with water-cooled tooling, a welding unit that consists of 3 power supplies, a tricathode torch, and a seam tracking system, a cooling chamber, and a camera. The last part of the mill is the pre-sizing section. Like the stands in the forming section, these stands have paired sets of tooling. These stands begin the sizing process, reducing the tube's diameter before it enters the annealer. Next in line is the pull-out section. As the name implies, it pulls the tube from the previous section. It also finishes the sizing process, straightens the tube, and uses a second encoder to measure the tube's length. Finally, the cutoff uses its own control system and a chipless rotary cutter for precision cutting. Let's take a closer look at each section. First is the entry section, which consists of the 3 components that feed the raw material into the mill. The process starts at the uncoiler, which has 2 arbors to hold 2 coils of raw material. The uncoiler rotates 180 degrees on its base. When one coil runs out, the next full coil is ready. The shear end welder performs 2 functions. First, it shears the tailing end of the outgoing strip, and it shears the leading end of the incoming strip to prepare the ends for joining. Second, it welds the 2 ends together so the mill can operate without interruption. The accumulator stores a large amount of material and thereby serves as a buffer. During normal operations, the uncoiler runs at the mill's speed. To fill the accumulator, the uncoiler runs much faster, as much as 2.5 times faster than the mill. When the accumulator is nearly full, the uncoiler slows down to match the mill's speed again. When the coil runs out, the operator swaps out the old coil for the new one and joins the ends. While this is happening, the mill continues to run at its normal speed, depleting the material stored in the accumulator. When the operator finishes the weld, the cycle starts over. The mill forms the raw material progressively from a flat strip to a round tube. It also closes the weld seam and begins the sizing process. The encoder takes an initial measurement of the material's length, and the entry guide table guides the material to the first forming stand. The forming section, which consists of breakdown and fin passes, works the material until the shape is nearly round. The weld box, welding unit, seam tracking unit, and cooling chamber work together to create a consistent, high-quality weld. The weld box contains 3 pairs of tooling rolls that close the tubular shape and maintain pressure on the tube throughout the welding process. It also provides an inert atmosphere that protects the weld from oxidation. As the tube moves through the weld box, the weld is carried out by 3 torches using the TIG process. This specific mill also has a cooling chamber immediately after the weld box that brings the weld temperature down rapidly. The welding section also has a camera that allows the operator to monitor the weld puddle and a tracking system that helps to keep the torches aligned with the weld seam. The last 3 stands reduce the tube's diameter before the tube enters the annealer. In addition to pulling the tube from the annealer, the pull-out section serves 3 functions. It uses 2 sizing stands to bring the tube to its final diameter after annealing. It has a 4-roll 2-plane straightener to remove any bow from the tube, and it has an encoder wheel to track the length of the tube as it leaves the pull-out section. This is to account for the tube's length, which increases as the tube's diameter decreases as it moves through the sizing stands. The information from the second encoder is fed to the last section, the cutoff. The cutoff uses a carriage that moves at the mill's speed to make the cut without interrupting the production process. From its home position, the cutting carriage accelerates to a speed that matches that of the mill. The cutting unit then cuts the tube to the programmed length, and the carriage returns to its home position in preparation for the next cut. The cutting process is carried out by a chipless rotary cutoff unit that uses 3 blades that orbit the tube, closing in on the tube as they revolve around it. It makes a waste-free cut with minimal burr. Now let's bring all this information together in a series of images. This engineering drawing of the uncoiler shows the 2 arbors that hold the 2 coils, and the specifications list on the right-hand side lists the pertinent capacities. Next is a drawing of the shear end welder, which is a fairly compact unit, along with its capacities. Following that is the accumulator, designed and built by T&H Lamont. It stands nearly 8 feet tall, but this is not its installed height. The bottom section of the accumulator sits below grade in a trough in the floor. This type of accumulator needs quite a bit of vertical space, so installing it partially below floor level puts all the unit's hardware and the control panel within easy reach of the operator. This brings us to the mill. At first glance, the most noticeable things sit on top. First is the mill's control panel. Second is the gas distribution system for the welding unit. And last is the monitor for the welding camera. Moving in for a closer look, the first item is the encoder. The encoder's wheel rides on the strip surface to measure its length. It's followed immediately by the entry guide table. Next is the forming section. On this mill, it consists of 4 breakdown passes and 3 fin passes. This is followed by the weld box and all the rest of the hardware in the welding section. After that is the pre-sizing portion of the mill, which consists of 3 passes. Next is the pull-out stand with 2 sizing passes, a straightener, and the second encoder. This brings us to the last item, the cutoff. Like the shear end welder and the accumulator, it has its own control panel that receives data from and provides data to the main controller on the mill. The entire production process is a complex undertaking, but the operator's job is simplified by the vast amount of information that flows among the control systems at the mill, the accumulator, the welder, and the cutoff. The process of designing, assembling, programming, installing, and commissioning such a mill has one goal, and that is to provide years of efficient, trouble-free service in making robust, durable tube or pipe products, regardless of the markets those products are destined for or the applications they serve. If you have any questions about tube or pipe mills or the production process, please don't hesitate to contact T&H Lamont.